speaker to the stage. This is the Devil's Quadrangle of platform engineering. And we have Sander from Akamai. I'm going to bring you to the screen. Hello, welcome.
Hi, ladies.
Nice to see you. I'm going to bring your slides to the screen. And with that, we'll duck off and let you take it away.
Okay, thanks. Hi, everybody. My name is Sander Rodenhuis, and I live in the beautiful city of Utrecht in the Netherlands. I've been involved in building Kubernetes platforms for over 8 years now, I think. And before that time, I think like 17, 18 years in IT infrastructure. But I won't go through my whole resume. Last year, the Kubernetes-based platform that was developed by my company got acquired by Akamai. So now I work for Akamai. And so we got acquired last year, and after an open beta period, the platform is now going to be generally available in around 4 to 5 weeks, I think. So over the last 7, 8, 9 years, that I was building platforms, I learned that building platforms is all about understanding constraints and trade-offs. And the Devil's Quadrangle of project management is a framework that can be used to make this like visual. And maybe you know or don't. It's the Devil's Quadrangle is an extension or an extended version of the traditional magic triangle. And in addition to time, cost, and scope, I think I need to also switch to the next slide. So in addition to time and cost and scope, quality here is added as the fourth constraint to highlight the importance of the final deliverables excellence. So that's the theory. And as you may or may not know, changes in one of these constraints will always affect one or more of the remaining constraints, which means you'll need to make trade-offs. And now I know that making trade-offs, especially for engineers, can be hard because I think we all own the art of always being right? But building a platform is not only about technology. So every technical decision will impact other of the constraints. And some of the trade-offs are scope versus time. So the larger the scope, the longer it takes. So the more time it will take to build it. Or time versus cost. So faster timelines will always, like most of the time, increase cost. Or scope versus quality. So increased scope can also lower quality because you have like a lot of things you need to pay attention to. And the last one, this is just an example, is the quality versus cost, because higher quality will probably also increase costs. Now, what I want to do is take a look at 2 cases of trade-offs that we run into like in the past when we were building our platform. And the first one I want to discuss is this is a quality versus scope and cost, because and it's about like implementing strict security guardrails, quality, that will result in a higher abstraction of the platform, which is the scope, and more developer friction eventually. Because you can tighten everything up or provide more room for customization and experimentation for developers, but there is no one size fits all. So what we did is, and this is the implementation part, and you can see on the right, I think, an example of the the web console of the platform, where you can see that a developer can create a workload, and that workload is based on a golden path template provided through a catalog. And this allows developers to use a template from the catalog and change any of the available values. So instead of providing a form where everything is fixed and you can only configure the options that are provided in the UI, here the developer can make a lot of customizations. And this is combined by a set of security policies in audit mode to provide feedback regarding the constraints from the guardrails. Now, another one is scope versus time and costs. And of course, a higher abstraction, as I already mentioned, is like the scope means more custom development. Because if you're trying to build like the next Heroku, where everything is like highly abstracted, it's going to take a lot of time. So what we did is instead of building our own dashboards or logging options within the console, we're using the available open source projects that are out there, which are probably already known by the developers that are using the platform. And this allows developers to access shared applications that are shared like on the platform in a multi-tenant setup. And it provides observability using projects as Grafana, Loki, Alert Manager. So you need to be, so we're assuming you have the knowledge to use these tools that are provided by the platform. And what I wanted to say is that success in platform engineering should not be a mystery. So it's all about making design decisions, doing trade-offs, and have a clear vision on the scope of the platform that you're trying to build. And if you, sorry, if you adhere to that, it's probably going to be a success. So here are some takeaways. I think the most important one is to ensure that all stakeholders understand the trade-offs that you're making. So it's all about transparency towards all the stakeholders involved. But also know which constraints are the most critical. Another one is to regularly ask for feedback from users, and constantly improve the platform, and maybe also reevaluate the trade-offs that were made in the past. And of course, what I always want to say is don't try and reinvent the wheel, because there's already a lot out there. And also kudos to the previous speaker. I think it was the Nice from Norway. Pretty cool stuff. But I also want to say that don't think like you're special, because there is already so much out there. And I think most of us, what we're doing when building platforms on Kubernetes is a lot of the same, yeah? But still, we're trying to all build our own platform because we think we are special. While I think that maybe around like 80% of the requirements are probably always the same. A little bit about the Akamai App Platform. So that is a pre-configured and fully integrated, curated suite of open source projects combined with easy developer self-service. And we made it available as a one-click extension for the Linode Kubernetes engine, which you can see here. So when you provision an LKE cluster in Akamai Cloud, or previously known as Linode, you can just say, yes, enable the app platform, and then it will install the app platform on your cluster. So it's a kind of self-hosted platform as a service running on Kubernetes. It's currently in open beta, and as I already said, will be available in or generally available like half of June. Also, the Akamai App Platform is free. So when you provision an LKE cluster, you don't need to pay anything like additional for the app platform. And most of the code is available on GitHub. I'm saying most of the code because some parts are still closed, but we're thinking also about making that open. So what you can do with the app platform is to build, deploy, expose, observe, secure apps on Kubernetes. Or if you want, you can use it as a kind of reference architecture when building your own platform. And use it as a kind of inspiration. I think that was it. Looking at the time, if you want to meet Akamai at one of the events that we're organizing, like all around the world, you can find the link here. And then I'm left to say, thank you.
Awesome. Thank you so much. And Sander, if you want to put the link in the chat to any of the resources you mentioned and the dev platform to try, I'm sure people would might be interested in doing that. Thank you so much for being here. I do like your comment about, not being special. There is a lot